Assalamu alaikum everybody. Okay, I'm here with a small little tutorial on how to calculate the mean, variance, standard deviation, and the coefficient of variation. And for reference, I'm taking two questions here. I'm taking question number 2, which will give me a sample data with 6 values. And then I'm taking this question number 3, which is actually a group data set that is taking the values of x and weights. I'm considering the weights to be the frequencies. I'm doing a few changes here. I mean, weights and the frequencies are regarded the same, and they're computed for variance, standard deviation, or the mean in a similar manner. Okay, so for reference, I'm just taking these two questions. Let me show you the questions now. Uh, I've already computed these questions. So this was question number 2 on page 110 and question number 3 on page 110. So in this question, we have an ungrouped data where the observations are given as these numbers. These are my 6 numbers. And in the second question, I'm given a group data, except for the fact that I've changed the weights to be the frequencies here. So these 4 observations were given, and these are the frequencies that I have. The rest of the procedure is done. So I've already computed this. I'll be explaining this. I hope you get it. I'm using the same formula which are given in the book. So some of these formula I've borrowed from other places so that you understand. So first we will compute. I mean, this is a hypothetical question. For reference, I'm taking this data. But the question is actually, the data is the same, but I've made up my own questions where I've added a few more things where we'll be computing the standard deviation, the variance, and the coefficient of variation. So how do we do that? What is the mean? The mean could be for a sample or for a population. So that is usually given in the question. Okay, so you have to consider the fact if you're given a mean, for a sample, you express it with x bar, or if it is given by, if the population data is given, you have to denote your value or label your value as mu. Similarly, if the variance is denoted as the sigma square, or the sample variance is denoted as s square. So the population sample differentiation has to be considered both for the ungrouped data and for the group data. You can see in the group data as well. We have mean, variance, standard deviation for a population, or we have sample variance or sample standard deviation. So the formula, by and large, in all books of statistics, they consider these facts, and that is why they're different. They're differently treated. But the main difference between an ungrouped data and a group data is the frequencies. So you get the frequencies with the group data, and you don't get any frequencies when the ungrouped data. Rather, you get an open form of data where the repetitions might be there. So how to compute the average first, or the mean? Mean and average are the same things. You have to sum up the numbers. This is the rule. Sum of the numbers, divide by the number of observations. So, I mean, you can take a look. I have summed it up and divided by 6, so I get my average. Similarly, for variance or standard deviation, there are 2 kinds of formula usually used in an ungrouped data or in a group data. You can get a formula like this, where the formula is like what this square showed up, or you can have an open form of formula, which is a computational formula. So this or this will result the same answer. You can see the difference there. There's another difference as well. You're having the population variance that is divided by n, where the sample variance is divided by n minus 1. This was explained theoretically in the lecture, so I hope you will remember this. Likewise, in a group data, you can see that the variance or the standard deviation for a population is divided by n, but for a sample, it is divided by n minus 1. So please remember that if you have a sample data, the variance will be computed by n minus 1 as a divisor. And if you have a population data, then the divisor will be n. Okay. How to compute the deviations? So I just told you what are deviation. Deviations are the differences between the observations from the mean. So we will take each observation and minus this 16 from it. You can see in the formula, each observation is subtracted uh, from the 16 and then taken in the squared form because we need a square of the deviations. So these are squared now, and then we finally need a sum of this. So a sum is here, and then you divide it by n. So this is my variance now. The whole sum, which was actually 94, C10 was my sum, 94, and this is divided by 6, so I've gotten my variance. The square root of the variance is standard deviation, so you can see I can take the square root here and I can take the standard deviation. Coefficient of variation, on the other hand, is standard deviation divided by the mean. So that is actually I've divided C13, which was the standard deviation, divided by B11, which was my mean, multiplied by 100. Usually a coefficient of variation is multiplied by 100. So this is a percentage figure. So this is how we compute all the important statistics. You can do it manually. You can use softwares, the variety of ways, but I was just explaining the formula to you in this tutorial. So I hope you get it. You can see the standard deviation is here. We have just taken the square root in the formula. And you can see the second method that I was explaining that, which is this computational method, this one, if you want to use. So for this, you need two things. One is the sum of xi square. So you need to take the square of each xi, sum it up, and sum the x values, and put these two numbers here along with the nth figure. You will end up with the same answer, with the same variance that we had here, 15 points. So you can try this back at home. Similarly, with a group data set, as I've told you before, that the difference between grouped and ungrouped is the frequencies. So you have to consider the frequencies here. So the observation, this observation is 6 times. So the formula demands us that we take the frequencies to be multiplied with x and then sum it up and divide by the number of observations. So I've multiplied the frequencies with x's here. I've summed it up. So 70.2 is my numerator, and the number of observations that we have are 19. Now, please remember, most of the students, they commit this mistake here that they consider that they have 5 or 4 observations. They do not have 4 observations. Actually, there are 19 observations since we had frequencies. Every number was repeating, a few times. The next thing that we are going to do, we are going to apply the variance formula. So what is the variance? The variance is actually the deviations we need to calculate, the observation minus the mean. So I've taken the observation to be 3.2 minus the mean. So the mean was actually, in our case, this was 3.6974. We computed this by dividing the sum by this number. So we got this. You can see the formula. I've divided I8 by H8, and we've gotten the population mean. So in order to get the deviations, there's a simple formula that I've used here. I first calculated x minus mu, which is actually x is this 3.2, and the mu value is 3.69. So that was squared and then multiplied with the frequencies. So what are the frequency? It is going to be multiplied with 6. So I'm double clicking this number. You can see in the formula, I've made this small little formula. You can do it yourself as well. And then finally, it is summed up. So you have to take a sum of all these numbers, which is actually 26 point. So you get the numerator by this. And if you divide it by the number 19, you will end up with the variance. So this is the variance that you've got. The numerator was divided by n. So actually, I'm computing the variance, sorry. So if I want to get the standard deviation, I just need to take the square root of it. So if you take the positive square root of your variance, you will get the standard deviation. You can see the same stuff in the formula. The square root should be on this whole formula. And finally, the coefficient of variation, where the standard deviation, this number, should be divided by the mean and multiplied by 100 to get this thing, okay? Considering the fact if I was having the population data, I will use the signs sigma, sigma square, and mu. But if I was having the sample data with me, I mean, if the question or the problem is with the sample that I'm considering, then naturally uh, that change will be there. Sample variance is denoted by S squared and sample standard deviation by S. And the same formula where the divisor previously we took N, which was 19. If I had a sample data, the only difference would be that I'll have to divide the sum of these squared deviations by 18 only. Okay, so I will divide sum of F minus 1, number of observations minus 1. And if I expand the same rule algebraically, I get this simple rule. This simple rule actually can be used in this fashion. You can see if I have my group data set, I just need to calculate two more columns where I multiply f with x. So you can see this is this fx square. This is my fx square. This is 285.94. I can put this up here. And then n minus 1 would be 19 minus 1. So that will be 19 minus 118 minus n 19 here. 19 minus 1 here, and the x bar figure. X bar would remain the same. You remember there's no difference whatsoever. So 3.69 will be that result which we have to put here, square it up, solve this whole number. We will end up with the same variance, and if we take the square root, with the same standard deviation. So this was a small little tutorial taking these two questions. I hope that you get this. Uh, in addition to this, I'll tell you that how to use your calculator here. I mean, if you want to do it manually yourself, you can do it very easily. You have to go, make sure that you're on the starts button, go to starts, and then what you want to do, you want to compute variation, go to 1, okay? So let me share the calculator with you. I guess the calculator was missing here. Let me just show you. Yes, I hope you can see the calculator on my screen. Yeah, okay. So yes, in your calculator, you can see now you can put in the same numbers. If you want to use the I mean the ungrouped data set, so let me just take you back to the ungrouped data set and show you the observations. We were having the observations of 10, 20, 21, 17, 16, and 12. So I will give this to the calculator. 10, 20, 21, 17, 16, and 10. So this is, let's hope I remember this, it's taking a little while. Okay, so this is, okay, so how to give data? Give to start, shift, start, and that, sorry, shift, start, and then type. So go to type, variation, so it's 10, 20, it was 10, 20, okay, 21, okay, and then 17, 16, and 12. So that's 17, 16, and 12. Okay, so we gave our 6 numbers. Now how to calculate the variance and the standard deviation? Go to just first you press the all clear button, then go to shift, go to start, and then you want to check the variation in the data. So just go to 2, and then on to you will see the mean. You can see 16 was the mean in our first scenario. Okay, and then you can check the standard deviation. So go to 4 again, and then this time press 3, press equal, 3.95. So these are your results. You can easily see that on the findings here as well. Okay, so 16 was the mean, and the standard deviation was 3.95. So likewise, if you want to give this, this group data to your calculator, you can do that very easily. Okay, how to give frequencies could be interesting for you. So make sure that you know you have the frequencies turned on. Usually the frequencies are not, because through the stat mod, if you're adding data, like for example, if I want to give data right now, so you can see I just have the a single column having the observations, and there are no frequency shown here. So let's just get out of stat for a while, okay, and go to shift and go to setup. So if you go to setup and you come a little down, you can see that there's another start button on 4. Press that and you can see the frequency is on or off. So if you turn the frequency on, again, now if you go to the start button, okay, and if you want to check the variation, you can see the frequencies as well. So you can easily give the data. You just give 3.2, that's my X number, equal. Initially, I'll just give the observations first and then the frequency. So 2 and then 2.5 and then 5. Okay, now scroll back and go to the first frequency. Okay, so what is our first frequency? 6. So type 6, press equal. Then type 3, which is our second frequency. You can check from the question. And then there is 2, and then there is 8. Okay, now since I've given all the data, you can press all clear, go to shift, go to stat, and then you check the variation in the data. So this is 4. Check for the mean. So the mean will be, like we computed before, is 3.69. As you can see in the spreadsheets as well, you can see this is 3.69. Let me take you back to the calculator. And then you can also see the standard deviation. So go to shift, start variation on 4, and then press on. Now you want to check the population standard deviation or the sample. Remember, this will compute the standard deviation with divisor n, and this will compute the standard deviation with divisor n minus 1. You already saw those formula in the spreadsheet. So because we did it for divisor n, so I will check on 3 and press equal 1.1821. Let me show you that on the spreadsheet as well. 1.18 was our standard deviation. Okay, so you can use your calculator. You can do it manually. You can, you can do it through a software, any software. That's a pretty simple stuff. But theoretically speaking, whenever you're working with variance, standard deviation, or coefficient of variation, make sure that you're equipped with the right kind of formula, and you have the theoretical background. What is it that actually you're doing? Are you doing it from a ungrouped data like this one? You can see in this question on page 1113. You see you're computing the mean here. Or if you're computing it from any group data set, let me show you any other question. You can see perhaps this question, you can see this is an ungrouped data, and this is requiring you to calculate the standard deviation, variance, and the coefficient of variation. Or sometime you may be you may be having this group data set with you where you may be computing a variance or standard deviation. So I've just showed you all the possibilities here. I hope that you get it. If you have any questions, you can always ask me back, and I'll be here to help you. Thank you very much, and bye-bye.